this is, if you look at all the biggest AI and machine learning driven products in
Yeah.
the world are driven by that. Okay. If you look at search at Google, it works with vector search. If you look at product recommendation and product search at Amazon, works this way. If you look at feed ranking at Facebook, that's how it's personalized. That's how it
Yeah.
works. You look at how TikTok just said that they're doing recommendation. That's how it works. Like
Yeah.
all the biggest and most successful recommendation engines, search engines, and feed ranking solutions and so on, they are all driven that way. Period. There aren't even any exceptions.
Hey, what's up, everyone? Welcome to Dev Interrupted. I'm your host, Dan Lyons, and today we're joined by Ido Liberty, founder and CEO of Pinecone. Ido, welcome to the show.
Thank you, man.
So you have a really cool background, and I'll list a few of the things that you've done. So you were the senior research director at Yahoo. Then you were the director of research and head of Amazon AI Labs. Both sound pretty interesting. You have, I think, a pretty good background in AI. You founded Pinecone, which you described as pushing everything I know to the limit and beyond. So that's probably a really fun company for you.
Yeah.
And we're going to talk about a lot of, the work that you're doing or that has led up to Pinecone and what you're doing at Pinecone and all that. But before we dive into those specifics, let's start a little bit about you and your background. How did you get into engineering and then move into like AI stuff? What's your story?
I've always been in the connective tissue, in the kind of in between space between engineering and math and algorithms and science and so on. And I always found it super fascinating how we can build better products, accelerate things, just do things more correctly, understand them very deeply with math and write the right algorithms and then pair them up with really efficient software. And for me, that was magic. Like kind of in the real world, when you do something better, it's usually 10% better, 20% better. If you manage to manufacture some car tires at, half the cost, like you've done something,
It's like revolutionary.
revolutionary. Exactly.
Yeah, it's like
And in computer science, and
yeah.
I felt like in engineering, we've gotten pretty used to like 10x being, we're pretty cavalier about 10x. Like when you do something correctly after having done it incorrectly, it's like 1,000 times better. It's like blows everything out of the water. It's completely different. And, for me, I guess the cloud was a huge catalyst to all the stuff that I'm excited about, because now your compute efficiency is the manufacturing cost of everything. Right.
Yeah.
And so suddenly, like if you do something 1,000 times better, it's 1,000 times cheaper. It's like making tires cost less, right?
Yeah.
So it's a fun time to be an engineer.
Yeah. I think it's like, since there's so much scale, like you mentioned compute. I mean, look at it's crazy what the world is basically running on computers now. So you get any gain that you get is multiplied 100x, 1,000x. It's probably one of the coolest things about our industry, like compared to what you were saying, like, I don't know, automotive or something physical. It's very difficult to take something physical. I don't know. You have like a airplane. I've been traveling around a ton, so I've been thinking about airplanes. It's like, okay, like if this airplane, it takes 3 hours to go from here to here. If I could go there in 3 minutes, okay, that would be like changing the world, revolutionary, but it feels so far away. In software, I think you can make some algorithm changes or new technology, impact everyone at scale. It sounds like that's kind of where your interest lies. Do you have a formal comp sci background, or like, what did you study?
I studied my undergraduate and a double major in physics and computer science, a
Yeah.
PhD in computer science, a postdoc in applied math. I published about 70 academic papers on algorithms and machine learning and
So
systems.
you're a smart guy.
I don't know about that, but I've definitely been very active academically. I actually even was an adjunct professor at Tel Aviv for 3 years. So
Great.
I'm very much into the weeds on machine learning and data systems. I mean, this is the kind of stuff that we live and breathe on a daily basis.
So eventually, I don't think it was right after school. I think you did some stuff in between, but you can correct me if I'm wrong. But eventually, you worked at Yahoo, and then you were in like AWS. I think you were doing.
Yeah,
What did you learn from those experiences from those jobs?
a ton. You know what I mean? I mean, this is so people don't know this today. Maybe the younger audiences are not aware, but Yahoo used to be like a powerhouse back in the day when it came to technology and machine learning. All the Hadoop stuff came out of Yahoo. A lot of the machine learning innovation came out of there. If you to this day look up machine learning papers from whatever 10 years ago, like half of the authors are going to be from Yahoo. That was like a kind of powerhouse of innovation. And we built a bunch of stuff that today is considered cutting edge. All the recommendation engines and spam blockers and abuse prevention and stuff like similarity search that we'll talk about today and vector search. And we built a bunch of those systems by hand. There was no TensorFlow, there was no PyTorch, there was no like MLOps. We had to build everything from scratch. And so, like many other things in life, when you build it yourself, you get a very deep appreciation of what's hard about it, what's easy about it, what works and what doesn't work. At AWS, I had the insane opportunity to actually move there and build the whole Amazon AI org that built SageMaker and like worked with a lot of different data platforms at AWS. And there I was, for the first time, wasn't building systems for internal consumption and for solving a problem. I was building systems for engineers to consume as infrastructure. And that's a very different kind of beast. Like then
Yeah.
like operations is different. Documentation is different. You have to think about things like pricing and monitoring and so on. And this is like, it's a whole different beast. And so getting an appreciation for that was, again, phenomenal. And kind of seeing how that is done from the belly of the beast at AWS was like an unbelievable learning experience.
That's awesome, and excited to hear about all of your knowledge. The topic that we have today is around vector data. Let's dive in there. Can you give us first like an introductory overview of what is vector data? What are the basics that we need to understand?
So to start with, I will say that a lot of your listeners will know what embeddings are and what vector embeddings are. And for those who don't, in general, when we use deep learning or machine learning in general to do almost anything, we have to featureize objects. So a machine learning model is a mathematical object. To work with math, you need numbers, right? So that you don't, the input and the output of a machine learning model is a vector. It's an array of numbers. Okay. It's not a string. It's not a JSON object. It's not a row in a schematized SQL table, a schematized, a relational table. It's an array of numbers. That's what it is. There's no other thing that goes into or out of a deep learning model, period.
Hmm.
Okay. Or any machine learning model, to be honest.
Yeah.
And so in many respects, that's how AI understands the world. That's how we label things. That's how we search for things. That's how we recommend things. That's how we do everything with data that uses AI. Okay. Now, when you work with these things, doesn't matter again if it's recommendation or search or anomaly detection or similarity search. If you're using AI, that means you now have these kinds of objects and you have to operate on them. You have to search through them. You have to change them. You have to like query over them. You have to store them efficiently. You have to, fetch them efficiently and so on. That's a new kind of infrastructure. That's not a relational database. That's not a document store. It's not whatever, not a keyword search application. It's a new kind of database.
Yeah.
And so for me, the explosion of this kind of data that came out of like NLP models. People today can now download some, BERT or GPT-3 or some other NLP model and convert a sentence in any language to these arrays, literally with a handful of lines in Python. Suddenly there's an explosion of both need and understanding of the fact this is how data is actually represented. As a result, there's an explosion in the need for something like Pinecone, where there's suddenly people have billions of these objects and holy hell, we have to do something here.
Yeah, absolutely. I mean, it seems like there's more and more of these objects. There's more and more people that are creating businesses, people with whatever it is, machine learning, AI. We're representing data in this way now. What problem did that then create now for the
Yeah.
engineering world and then for the
Mm.
consumers?
So I would like to think about it more as what you're trying to do with those things, okay,
Mhm.
and what value they bring rather than what problems they cause. Because in the end, we have objectives. Like we're trying to build something cool. We're trying to bring value to the business or the product, and we have an end goal in mind. And the question is, how do you do that with vector embeddings, and how do you do that with AI? And we can talk about very wide range of applications, from semantic search in text to anomaly detection in time series data or image search or whatever. But I'll give you as an example something kind of esoteric, just to kind of trigger people's creativity. Right? There's a small company. I forget where they're based, but they built a face detection for cows application to help manage cattle. Right? And so I don't know exactly how everything works on their
Yeah.
end. So again, we own the infrastructure, but we saw that. I'm assuming they somehow cropped the picture of the face of the cow, and then they
Yeah.
search, so they would take that image, embed it using, computer vision models into a numeric representation of that, and search it in Pinecone for the most similar other pictures, right? And those will almost always be the same individual cow.
Yeah. It's like an
I
ID
think,
mechanism.
yeah, it's
Identify.
an ID mechanism. So now
Yeah.
you don't have to manage it in the same way that people used to, I guess, right? I don't grow cattle, so I'm not entirely sure why that's
There's a
so.
lot of it. There's actually a ton of startup money going in farming and
Yeah.
I'm not surprised. Try
But
to
the beautiful thing
modernize the whole
about
thing. Yeah.
But the beautiful thing about this is like a handful of people in a company that's not, it's obviously a tech company, but I'm assuming they don't have like a massive AI department,
Yeah.
uh,
Well, they probably
they're
don't
able to
want to.
build something
Yeah.
very, very advanced by putting very basic, by putting building blocks together. And
Yeah.
that's phenomenal, right? And you would see this with text, we see this with images, we see this with a bunch of other applications as well. It's kind of cool.
So is the application you gave I guess kind of like a search example,
Yeah.
or hey, like I have this photo,
Yeah.
whatever it is. In this case, it's a cow's face, which is perfect. And I'm searching, I guess, a database or maybe a more modernized version of a database. And I'm getting a result. So is
Yeah.
most of the like when the reason we're talking about vector data or like the is it mostly around that search or
Correct.
pattern recognition?
Correct. So it's the what the database does best is search, is retrieve similar items or items that are, again, think about the input as a vector. So think about that
Yeah.
as an array, like in the same way that you can think about distance on distance between 2 points in 2 dimensions, or in 3 dimensions. You can think about them also in a million dimensions or 1,000 dimensions,
Yeah.
analogously, right? And so the math works exactly the same. You can search for stuff that's within some distance away from some place in space, or you can say everything that correlates the most in some direction in space and so on. It's like a geometric question.
Yeah.
And those are kinds of
That's really
searches
cool.
are the things the database does that is built for. So nearest neighbor search, max dot product search, those terms. And if not, it's not important. The point is that people who build machine learning applications, those are the building blocks that they need, right? To
Yeah.
the well known, well understood by that community. And that's what they need to build those solutions.
Yeah. No, it sounds awesome, and I'm sure like the company that you described there, they don't want to necessarily build all of. I mean, building this from scratch. That's not what the value of their company is.
Yeah,
They're
of
trying
course.
to do something with like farm animals, like not build like the technology to be able to
Yeah,
do that.
100%.
Um,
And it works on both small and large scales. I mean, you see like uh, building something relatively small, like this application, right,
yeah,
is actually not terribly hard. Like a handful of engineers can put it together in a few months, right? But if you're a tiny startup, you don't have a handful of engineers for a few months. You want to cobble
yeah,
something together in a few weeks and you want to get out the door, right?
yeah,
Uh, and the same thing holds for large companies. When you have huge applications, yes, you might be willing to spend a few engineers for a few months, but now your problem is so much bigger that you'll need 10 engineers for like 3 years.
yeah. There's two different things coming to mind for me. I'll start with the Yeah, I'll start with the first one. If I'm an engineer, so I'm a developer listening
Yeah.
to this pod, or maybe I'm a head of engineering.
Yeah. Yeah.
When should I be utilizing this vector search, or like when is the situation where it should pop into my mind?
Yeah.
Oh, I heard that from Edo. Let me look into what's available. Maybe it's
Yeah.
Pinecone, maybe it's something else. But what are the like engineering applications for this where it should pop into my mind that vector data or utilizing the search is the best or one of the best solutions?
Yeah. So first of all, we see a lot of people use it for semantic search. So that is where you want to search pieces of text, but that correlate by what you want back are not necessarily pieces of text that contain a certain set of words, but rather that are the most relevant based on your machine learning model. Okay.
Hmm.
And so people ask me about, text search, and I keep telling people the text isn't that thing. There's no such thing as text, right?
Yeah.
uh, Emails and resumes and legal documents and tweets and Jira tickets and whatever. They're all text, right? But they are very different objects and they mean different things. And searching through them is different. And your application on top of them is different, right? And so if you're trying to build a specialized search solution that searches by context and meaning and not by does it contain this word or that word, right? That's how it's built today. Nobody is building advanced search solutions on old, keyword based.
Yeah.
Doesn't happen anymore, right? You take those documents or those pieces of text, you featurize them with deep learning models, and you search through them. Same thing with images. There, you really don't have any other option. So you do the cow detection thing. You go to the deep learning model, you crop it, you embed it, and then you use the object search through the catalog. People do labeling. If you have large sets of examples, you might want to say, hey, I want to find, you know, I found something suspicious or something of interest.
Yeah,
Give
I
me
was thinking about anomalies,
yeah,
kind of
yeah.
like
Give
the
me 100 other prompts. It looks
anomaly detection or something like that.
100%. So
Yeah,
this was like find 1,000 other cases where something similar happened. I want to look at that because this thing is I don't know. It's curious. I don't know whether it's like good or bad. Let me search my space more efficiently, right? Instead of just start to peruse the data and hope that I find something similar to it, right?
yeah,
So people do a lot of security applications and
security.
stuff
Yeah.
and so on. So
Have you
yeah,
seen
that's all
anything? And
those are very
I'm
common.
just guessing here. Have you seen anything in the health sector? So I'm thinking of like disease or like I've been seeing some things either because the photo came there. I can take a
Yeah.
photo of something and then figure out oh, you might have this disease or this or that. Is there
So
anything
people
there?
do three main things in the medical domain. One of them is really image based, like you said. So all the medical imaging stuff is very much falls in line with computer vision use cases. People very much look into doctor's notes and all of that. So like the medical history notes, I forget the name of the system, but they're like a handful of systems that store and houses data. And from what I understand, it's a mess. Again, I'm not an expert in this field, but I hear there's a ton of structure and knowledge that is being just kind of lost in the whatever into the ether. And the last one is actually very close to pharma, drug
Yeah.
discovery,
Drug
you know,
discovery.
the chemical side of things. Now you have billions of molecules and they have binding sites, and you're searching through good matches and searching through potential chemicals to look at or molecules to investigate and so on. So all three are very active directions that people go in.
Yeah. What I really like about it too, and then we'll get into Pinecone in a little bit, but most of the applications, at least that we've talked about so far, are like super cool or like advanced things are like advancing humanity. I would say leveling up what we're able to do, drug
100%.
discovery, purity related stuff, even like what you're saying with like farming, agriculture, all of that. If we took it the other way from like a more consumer perspective, is there anything that like like a bunch of consumers or something that everybody would know, but behind it is vector data search? Is there any like really, is there, or is it only like this super advanced
No, I mean, man,
capabilities?
this is if you look at all the biggest AI and machine learning driven products in
Yeah.
the world are driven by that. Okay, if you look at search at Google, it works with vector search. If you look at product recommendation and product search at Amazon, works this way. If you look at feed ranking at Facebook, that's how it's personalized. That's how it
Yeah.
works. You look at how TikTok just said that they're doing recommendation. That's how it works. Like
Yeah.
all the biggest and most successful recommendation engines, search engines, and feed ranking solutions and so on, they are all driven that way. Period. There's no even there aren't even any exceptions. It's like that
Yeah.
is
This
kind
is,
of the
this is how it's
definitive.
done.
That's how it's done, right?
Yeah.
Now, most companies can't afford to be, they're not Facebook or Amazon or Google, they can't afford to put the head count over the many
Yeah.
units that they needed to actually build those solutions in house. But as a paradigm, as like how the machine learning works, how the data flows, that's been proven in the biggest possible scale.
Yeah, so I mean, you're kind of saying like these big companies have the resources to build it in house,
Yeah.
probably with really large teams. If we go from a lot of money probably spent to make it happen,
Oh yeah.
why is it so difficult? Like if we use your academic hat, or is it difficult? And if so, why is this hard to create on your own?
It goes back to the beginning of the conversation. It's hard to do right?
Yeah,
It's hard to get the 1,000x, that we talked about, right? Pretty much every company can put together something bad. It's like
I
it's
can make a
not so
shitty
hard.
version of this.
No, exactly. If you have a tiny amount of data
Yeah,
or whatever, like you have to run a query once an hour, then forget it. Anything, we'll just throw anything at the wall. It'll stake. It's gonna be fine. Okay.
yeah,
The second you try to do anything interesting, like the second you try to go faster, have more items, be highly available, be very accurate, and so on, things become complicated, right? And you might look at some of the academic papers that I've been publishing on for the last however many years, right? These are pretty complicated issues. It's like high dimensional geometry and rounding in different ways and clustering in different ways and quantization and, like the advanced hashing techniques and all that stuff. It's like, this is complicated stuff. It's still active research in the world, right?
yeah,
And at the same time, you have to marry the algorithms and the math with super high performance code. So our entire code base is pure Rust. We dive into like optimizing SSD access, optimizing AVX instruction sets, like squeezing out the bits and the bytes. It's really hard to get that entire thing like locked in a way that you truly can just run with it, right? And so for me, that's exciting. Like for me as a geek, I love those
that's
things.
really
I
cool.
can, I can do those all day long. For a lot of companies, that's not the specialty. That's not what they're good at. And that's not what they want to invest in. And
Yeah,
I think,
yeah. So it sounds like, okay, there's a lot of advancement that's been made here. we know building something like this on your own, especially if you're a small company, not going to be like a great use of resources. But
Yeah.
for companies like that you have, or the people that are really close to it, what are the existing challenges? Like, what have we been able to do, and where are we now stuck?
So it's great that you asked that. So we are constantly improving. For example, like we're looking very closely at our cloud infrastructure on how. So we're a cloud native database. So everything's in the cloud. There's no like on-prem, or there's no like, can't download Pinecone, right? It's a managed service. It's not
Yep.
unlike DynamoDB or, Spanner or something, right?
Yeah.
For us, driving the cloud architecture to be extremely efficient and at the same time extremely nimble and predictable is a Herculean effort, right? I can't even explain to you the intricacies. I mean, I can, but it's gonna, we'll talk for 10 hours on how complicated it can be. And this is, you know, uh, you can ask people to build like Snowflake and Databricks and whatever these other cloud systems,
Yeah.
why that's hard. But there's noisy neighbor issues and predicting, even monitoring to be able to like for doing billing is hard. Like it's that difficult, right? That's kind of cloud level. Uh, Below that, it's a ton of really complex engineering on managing disk, managing blob storage, like streamlining all of those, like the hierarchy of caches and hierarchy of storage, making that like super dynamic, super efficient, and so on. The data structures themselves, the algorithms themselves, and how you accelerate search and how do you accelerate the queries and so on. All of those are open questions. We've already made great strides, but
Yes.
we believe there's somewhere in 10 and 100x still in the flanks waiting to happen.
Yeah. Is it around like speed and efficiency at scale? Is that the
Correct. Speed and efficiency, and at the same time, accuracy. Again, so search
Yeah.
has to do with
Yeah.
relevance. The more relevant you can be, the better.
Yeah.
And
I mean,
so,
if that's like quality to me. If that drops too low, then it's not useful. If it's,
correct. I mean, exactly.
yeah,
You can return
that's the value.
exactly.
Yeah.
You can return wrong results very quickly.
Yeah.
There's a question. It's like, oh, return null. I can do that immediately.
Yeah.
So yeah, of course, you want to balance those out. You want to push the boundary of how much you can do, but keep a very high bar on the quality of the outcomes.
Is there anything happening with open source around this? Or is that everything managed service, which is also great, but is there anywhere to contribute to an open source project for
Yeah.
people?
So there are open sources that look at vector search as a primitive. There's a project called Vice, came out of Facebook, a project called HNSW, written by Yuri Malkov, who's an advisor to Pinecone as well. There are, there's a handful of open source projects that do well. There are even open source companies who try to build vector databases as open source. What we find is that people really appreciate the managed service offering.
Yeah.
You know, if you've ever ran an open source, if you internally ran an open source distributed systems as a system, as a service in your company, that's a lot, right? You have
Very
a
a lot of effort.
Kubernetes cluster and monitor it and run it. And when something happens, you have to go figure it out and so on. So a lot of our best customers came actually after they tried to go to production with something else and they had an outage for a week and they had no idea what the hell to do.
Yeah, of
And
course. I mean, that's the whole managed service play. We've seen that many, many times, right?
Correct.
You have to
And
have
so-
if you want to do it yourself, you need a whole team.
Yeah. And so and by the way, one of the things that we are very much driven by, and again, for me, again, as an engineer and as a scientist is exciting, is like, how simple can we make this? Can we make this like a completely like plug and play thing? Just like drop your data and run queries and don't worry about anything, right? How close can we get to that ideal, right? And that's hard. There's a lot of automation, a lot of like optimization on our end, a lot of predictive stuff. We have to really figure out a ton to make that possible. And for me, again, as a consumer, as an engineer myself, that's what I love about systems. Like if something always does what I want it in a predictable way and I don't have to tweak with it, I don't have to worry about it, I sleep better at night. I'm like, we know this as consumers of like cloud. Like if you put something in S3 or in GCS, like you don't worry that it will go away. You just put it in blob storage. It's done. It's there. Like you're not losing sleep over it because you've gotten used to the fact that this is a very, very stable, and predictable solution. That is where we're aiming. Like we want this to be a foundational layer that people just like don't have to worry about anything. It's like, oh, it's great. My vectors are in Pinecone. I can whatever. Like I'm done. This is good. Now I can use them. Now I can do everything with them.
Yeah.
I don't have to worry about any of it anymore.
Yeah. And I assume with Pinecone traditional model, I can start small for free, something like that. I can try it out and grow from there on usage
Yeah.
or yeah.
100%. It's
Yeah.
100% usage. There's a perpetual free tier. So it's not a trial. It's an actual free tier forever.
Yeah.
We
That's
use
awesome.
it, standard, which is paid, and then like enterprise and it's like the usual
Yeah.
plan.
The usual model. But it's good to be able to start free without maybe disclosing too much of like all the secrets
Uh-huh.
with Pinecone. And you can talk generally about the industry, but what's next? So it's like, okay, I know I have a managed service. I can get my stuff done with Pinecone. Takes a lot of the weight off of me, but what's coming now in the next few years? Where do you think the industry is going? What's interesting to you all at your company?
I'm a little bit of a purist when it comes to like tooling and in this industry. And a lot of people talk about some unifying frameworks and all sorts of like magic bullets and so on. I personally don't believe in that. Okay. Time will see if I'm right or wrong. But what I think will happen in the next 3 to 10 years, okay, is that the set of building blocks on top of which great machine learning and AI applications are built are just going to solidify and crystallize, and the interfaces are going to become a lot more well defined. If like 10 years ago it was just a zoo of libraries and shit, nobody knew anything. Today, it's like very well understood. You have models, you have training frameworks, you have ML ops layers that run the models in production, you have monitoring tools, you know, they have those interfaces starting to be very well defined. Same thing as vector databases, feature stores. There are going to be, I don't know, like 10, 15 different kinds of infrastructure. In each one of those, you're going to have 1 to 5 to 10 players with great solutions. And every big machine learning application, doesn't matter if it's a search engine or cow face detection, or if it's feed ranking algorithm, right? All of those are going to use a combination of the building blocks, right? And they're going to put them together in the same way that other fields have matured from microservices architectures to security and so on. They have a very well-defined set of tools. The same thing is going to happen here. And I think the true acceleration in development and in the market is going to happen when this new generation of machine learning engineers really kind of absorbs the different components and know exactly how to combine them. And they started like build stuff in a much, much, much higher pace. By the way, machine learning engineers, based on, I think it's a survey that was done by LinkedIn a few months ago, was the fourth fastest growing job in the US.
Yeah.
And not in tech, like in general. The number
Just
one
everything.
is like vaccine specialist. Okay. This is
a-
like overall, right? So there's like a
Yeah,
new
I
generation
believe
of
it.
developers down the pike.
Yeah. Yeah. I mean, if you're into that stuff, probably like really good career path right now for you.
Yeah.
But
100%.
you know, it's one of those things that for the next, I don't know, 50, 100 years, we're gonna be doing this stuff and studying it, and everything's gonna utilize it basically.
Yeah,
All
100%.
industries.
I don't think you can be a successful company without having that in your arsenal.
Now, it's not necessarily has to be the most futuristic, but before we wrap up, I did want to touch on one point. You recently announced that it's now possible to conduct searches combining both semantic and keyword searches. You're calling it hybrid search. Just a little bit on that. Why is it important? What's the significance of it?
Yeah. We started by saying, hey, a lot of people are using this for text, or using keywords like semantic search for stuff that look like text, right? And everybody knew that a keyword search was kind of ran the course, and that's it. It's like we've asymptoted on the best thing we can do there, and semantic search and vector search was challenging that and now performing it. What we found was that in some cases, it actually, like, knowing a specific term or knowing a specific name or something can boost the semantic search. Can actually, like if you make the semantic search keyword aware, then you actually get some extra right? And that a lot of customers who are used to searching by keywords, who are used to having that power, didn't want to completely give it up. And so we said, hey, we can do the quote unquote dumb thing and just, have keyword search and vector search live side by side and somehow kind of put some spit and gum and make them play nice with each other. Right.
Yeah.
But it's not how we roll. Right. We said, okay, let's go back to the kind of think in foundational ways of why is this important? How is this important? How we should really build this. And we found some two things that I think are very interesting. One of them is that if you truly combine the two scoring mechanisms, so you make really semantic search and you make it keyword aware in the same engine, right? Or in the same scoring mechanism, you can get better results, period. This is better than keywords alone or semantic search alone.
That's
Okay?
very cool.
So that is significant, right? This is like we said about in the end, people care about accuracy. The second thing we figured out was that algorithmically and data structure wise, and like at the core engine, we can actually do both of those together. We can actually fundamentally get the right thing working without having, the two systems and combining them and like doing some kind of black magic. This is properly working inside the core engine. And so for us, that's a big win for all of our customers that use Pinecone for text on, in all its, variety. That's a huge win because now they can go and figure out even better ways to get results.
Yeah, that's awesome. Totally makes sense to me. As we're wrapping up here, I think there's like a few really good takeaways. I mean, first off, with Pinecone, if you're looking for a vector database managed service, you can start for free. We talked about that. Good thing to go. If you're looking for a career, right, or something to study, machine learning, that type of stuff, you're a newer developer or want to make a switch, definitely something to look into because you can see the industry trending in this way. Ido, is there anything that we didn't cover or something that you want to say about the industry for the engineers listening?
No, I think you nailed it. I think it's look. I mean, I'll maybe say it again in a slightly different way. I do what I do because I love it. Okay, because I'm pushing myself to the edge. That and we are constantly grappling with like the boundaries of like physics and math and computer science and how computers fundamentally work, right? And if you're an engineer if that's exciting to you, if like a systems engineer or a high performance computing person or a, machine learning expert, and you like grappling with really hard problems, then Pinecone is a great place to come to do that. And in general, I mean, this field of these companies who operate at the edge of machine learning and data and systems for the next generation are going to be places that are going to grow and improve and do really innovative stuff in the years to come. And that's a great career choice.
Awesome. Well, Ido, thanks for coming on the pod today, getting us caught up on vector databases. It's been a really, I think, interesting and educational conversation. Thank you so much.
My pleasure, man.
All right. And also, thanks everyone for joining us today. A quick reminder for our listeners, if you haven't already rated and reviewed the show on your pod app of choice, particularly Apple Podcasts, please do so. Reviews are a crucial way that our show gets discovered. And one last time, Ido, thanks so much for coming on today and educating us all on Dev Interrupted.
A pleasure, man.